Hello guys, in this series of videos we will be dealing with grade 10 physics. Now the first chapter of this book is about the science of physics, and the first section is about what is physics. So if we define physics, we will say that physics is the study of how things move and how things work in the world, okay? The word comes from the Greek word physis or physis, which basically means life or nature. Okay, now you have several areas within physics. The first one is mechanics. Now, mechanics is about motion and its causes. Okay, motion and its causes. For example, you have an object that is falling from a certain height. Okay, so falling objects are related to mechanics. You have friction. Okay, you have two bodies. Okay, and there is a friction between these two bodies. Okay, so this is basically also related to mechanics. You have weight, okay, which is related to mechanics, and you have spinning objects too. You have thermodynamics, okay? Thermodynamics is about heat and temperature, okay? And examples of it can be like cooking, when you're cooking something, okay? Melting, freezing, okay? These are all related to thermodynamics. You have vibrations and wave, okay? Sound is an example of vibrations and wave. Springs, for example, you have a spring, okay? This spring, if you apply a force on it, it goes back and it goes forth, okay? It goes back and forth, okay? Any object that makes a repetitive motion is basically related to vibrations and wave phenomena. Sound is related to vibrations and wave phenomena because you basically have particles in the air, okay? You have particles in the air when you are talking, okay? So these particles will be vibrating back and forth in a fixed position, okay? And they are making a repetitive motion. If you have a pendulum, okay, for example, you will tie an object, okay, you have an object, and this object is tied to a rope, okay? You have an object, and this object is tied to a rope, okay? This will be what, for example, you have seen the clocks, okay? Wall clocks, okay? They have something like this, like a pendulum, okay? And so this pendulum is going back and forth, okay? It's making a movement like this, okay? So this is what basically, this is a repetitive motion, and this is related to vibrations and wave. You have electromagnetism. Basically, you have magnets, electricity, light. These are all related to electromagnetism. You have relativity, okay, which basically is related to particles moving at any speed, including very high speeds. Okay, you have particle collision, you have particle accelerators. These two, relativity and quantum mechanics, you don't have to know anything about them, okay? Just know that they're about, relativity is about particles moving at any speed, and you have quantum mechanics, which is about the behavior of subatomic particles, okay? You have atom, and you have its parts, electrons, and its nucleus, okay? Basically, the subatomic particles and how they behave is related to quantum mechanics. Now, we have scientific method, okay? Before we talk about the scientific method, let me tell you that when you're, for example, having a problem with something, okay? For example, let's say your phone or your computer, okay? It doesn't work, there is an error, okay? Your computer shuts down, okay? Without any reason, okay? So you start by what? By checking if there is something wrong with the computer. Or if it's your phone, you start by checking if your phone is having a problem, okay? Now, when you are studying a phenomena in physics or in science in general, okay, you first start by observing and asking questions, okay? So the first step that you do is you start by observing and asking questions, okay? You look around, you ask questions, okay? Then you will be what? You will be making hypotheses, okay? I'll be giving an example about this, okay? when you are making a hypothesis, okay, you basically explain your observation about the phenomenon, okay? Then you'll be testing the hypothesis, then you'll be analyzing your data, deducing your results, and finally publishing the results. Let me give you an example, okay? Let's say you have two objects, okay? You have a ball and you have a ball and you have a paper, okay? You have a paper like this. Okay, you have two objects, okay? A paper and a ball. If you let these two objects fall, okay, you'll see that the ball will be falling much faster, okay? The ball will be falling much faster, and the paper will be what? Will be floating in the air, okay? You'll see that the paper is still floating in the air, and the ball has what? Has hit the ground, okay? If this is the ground, okay, you'll see that the ball hits the ground much faster than the paper, okay? And you'll be asking why this happens, okay? You'll be asking why this happened. You'll be asking a question, okay? So you have observed two objects. First, you have seen that the ball falls much faster than the paper. So you observed, and you'll be starting to ask questions. Why this ball falls much faster than this paper, okay? So you did what first? You observe and ask questions, okay? So you did what? You asked questions and you observed these two objects, okay? Then the second thing you will be doing, okay, you will be formulating a hypothesis, okay? You will be formulating a hypothesis, okay? So for example, you will be saying that because the ball is much heavier than the paper, so you will be saying that that's why it's falling much faster than the paper, because the paper is lighter. So you will be formulating your hypothesis. What is your hypothesis here? Your hypothesis is basically saying that heavier objects fall faster than lighter ones, okay? Now let's see if this is correct, okay? Then in the third step, you will be testing the hypothesis, okay? So you will bring a paper and a ball or any other object, a rock, let's say, and you'll see if it really is like this, okay? So you will first let the ball and the paper fall, and you'll see that the ball falls much faster. Now you will try something else, okay? You will crumble this paper, okay? Let's say you will crumble this paper, and this time you will let both of the objects fall, and you'll see that the crumbled paper falls exactly at the same speed with the ball, okay? And now you see that your hypothesis is not correct, okay? So you will come to the fourth point, okay, which is analyzing your data, okay? You will be analyzing your data, okay? So you will say that the rock falls quickly and the paper floats down slowly because the crumbled paper is facing more air resistance when it is not crumbled, okay? So you'll be basically comparing the motion of the two objects, okay? Then in the fifth step, you will conclude results, okay? You will be concluding that, let's deducing results. So the fifth step is deducing results. So in the fifth step, you will be deducing that air resistance, not just weight of the objects, affects how objects fall, okay? In the example you have, when the paper is not crumbled, it falls much slower than the ball, okay? But when you crumble the paper, you basically reduce the contact area with the air, okay? So the paper is less exposed to the air, so it will be falling exactly at the same speed with the ball. So it's not just weight, but also air resistance that affects the fall of objects. And then lastly, you have publishing your result, okay? Publishing your result, okay? So for example, let's say you did this experiment in your class, okay? So you'll be sharing this experiment with your classmates, okay? And explain how air resistance influences the speed at which objects fall, okay? This is basically how scientists study natural phenomena, okay? But here, when you, for example, in your example, when you share the result with your classmates are going to do the experiment and they will support your data, okay? This is exactly what happens when a scientist is studying natural phenomena. He will be studying the natural phenomena, he will be collecting his data, building hypotheses, okay, testing the hypothesis, analyzing his data, deducing results. Then when he publishes the results, other scientists are going to do exactly the same experiment he did, and they are going to increase the validity of the theory, okay? They will see if his theory is correct or not, okay? If the results are not supported by the scientists, then they will be back to building new hypotheses, okay? The same example that you did here, okay? So if you define scientific method, you will say that it is the study, it's a systematic method of studying natural phenomena. You basically have some steps. You follow these steps when you are studying a natural phenomenon. Okay, a system, guys, is a precise part of the studied region. Okay, any thing that is under study is basically a system. Okay, for example, this is a system. Okay, the ball and the paper experiment is also a system. You have model, okay, and you have a system. Okay, you have model and you have a system. A system, guys, imagine that you have a car, okay, that you have the parts of a car, the fuel, the engine, the steering wheel, okay, the wheels, the tires. All of these are what make a car, okay? So a car is a system. A model of a car is what is a toy car, okay? A model of a car is a toy car, okay? So a model is basically a simplified look of the studied system that shows the elements that affect the phenomenon, okay? So for example, if your teacher is explaining the motion of two cars, he cannot always bring two big cars inside the class and tell you this is a car, okay? So he'll be basically bringing a toy car and show you that this is a model of a car, okay? So a real car is a system, and a model is a toy car is a model, okay? Basically, you have also with biology, for example, if your teacher is explaining skeletons, any other organ, they're basically going to bring a model of that organ, okay? Not the real organ, of course, okay? So a real organ is a system, a model of it is a opposite of it is a model, okay? They basically bring a model to explain that organ, okay? You have controlled experiment, okay? Controlled experiment is basically when you fix a variable, okay? Sorry, you fix other variables, but you change only one variable, okay? So let's say you have a tree, okay? You have a tree and yeah, this is a tree, okay? You have a tree and there's also, of course, sunlight, okay? You have the soil too, of course. So this is soil. You have the color of the leaves, okay? Okay, let's say the color is green, and let's say it's an apple tree. Okay, so this is apple tree. Okay, now all of these guys are what are fixed variables. For example, the soil, you cannot change the soil, you cannot change the minerals that are in the soil. Okay, you cannot change the color of the tree. Okay, so the color of the tree cannot be changed. Apples, okay, if it's an apple tree, you cannot make it an orange tree. Okay, the sunlight, the amount of sunlight it gets, you cannot change that. There is something you can change, guys. Okay, so all of these guys are called fixed variables. Okay, all of these are called fixed variables. Okay, you basically have fixed these variables, and you only change one. Okay, you only change one variable. So what? Water. Okay, you can give a what we call a tank of water. You can give it no water. Okay, it's basically your decision. Okay, so this is what this is the single variable. Okay, single variable. Okay, which you are going to be what? Manipulating. Okay, so tomorrow you'll be giving this tree some water. The day after tomorrow you will not be giving it water. Okay, you might feel that the tree is a little bit dehydrated, so you'll be giving it more water. So it's basically a single variable that is changing. Okay, you are manipulating one variable and the other variables are fixed. Okay, now we have section review. Okay, section review is really easy. Name the areas of physics. We have studied the areas of physics. Identify these areas of physics that is most relevant to each of the following situation. A football game is what is mechanics. Preparing dinner because you are using heat to cook, so it's thermodynamics. Hearing the call for evening prayer, so it's basically sound. Okay, lightning in a thunderstorm, it's related to electromagnetism. It says most relevant. Okay, so some of you might say that lightning in a thunderstorm is also related to optics and thermodynamics. Yes, you are correct, but it says most relevant. So here it's most relevant to electromagnetism. You are wearing a pair of sunglasses outside in the sun, so you have sunglasses. So it's related to optics. Okay. You have this one, physics in action. 3. What are the activities involved in the scientific method? You have observation and asking questions, formulating hypothesis, testing hypothesis, analyzing your data, deducing results, and publishing your results. Now, physics in action, you have an ally, okay, and testing each of the following tests on a lightweight metal alloy proposed for use in a sailboat cell. So the first one says, if testing the effects of collision on an alloy, okay? So it's with collision, okay? So collision is what is basically related to motion, okay? So this is motion, okay? So the first one is what is related to mechanics, okay? B, testing the effects of extreme heat and cold. So this one is what? You have extreme heat, so this one is thermodynamics, okay? Thermodynamics. Testing whether the alloy can affect the magnetic compass needle. So it's magnetic, so you had what? Electromagnetism, okay? So this is related to electromagnetism. This is it for today. See you in the next lesson.